So in this video, I'm going to go through and work on the right triangle similarity worksheet because I feel like this would probably be good for you guys to have an opportunity to look at this and then go through it like one question at a time, or at least the ones maybe that you struggled with. So, all right, so first thing, remember our setup is that we have a right triangle, and then the altitude from the right angle to the hypotenuse created two additional right triangles, and the deal here is that all three of those right triangles are similar. So question number one asks us to just name the similar triangles. Now, remember that order is not important, so it doesn't matter what order we write these in, but I'm going to start off with Papa Bear. So I'm going to call him TSR. Whoops. Let me move over a smidge, sorry. TSR, so Papa Bear is TSR, and he is similar to Mama Bear. So I did TSR, which was long leg, short leg. So now I need to name Mama Bear long leg, short leg, and that would be TVS. So Mama Bear would be TVS. And then that is similar to Baby Bear. Now, again, I did long leg, short leg when I named this over here. I did long leg, short leg when I named Mama Bear. So now I need to do long leg, short leg of Baby Bear, which is going to be SVR. So SVR. Now, this is good because as we go through these questions, I can see, like, for example, this right here. If I'm looking for SV, that is, the side of that is going to match up with RV or RS. So it's one of those things where this, writing this statement out can be really helpful in lining up your triangles correctly. Okay, so I'm using this picture for each of these, and they're all separate questions. But the first thing that I want to do is to redraw the triangles, because I think that that is the most helpful way. And actually, I'm going to turn this upside down. So I have the lines here. All right, so first we have Papa Bear, and Papa Bear is the largest right triangle. His right angle is S, his short leg is SR, and his long leg is TS. So here is TSR. All right, then we have Mama Bear, who is not as big as Papa Bear, but Mama Bear, her right angle is the V, her short leg is VS, and her long leg is TV. So again, TSR and TVS match up right there. Then we have Baby Bear over here, who is the smallest. His right triangle is the same as Mama Bear's. And then his short leg is VR, and his long leg is SV. And again, that matches up with our statement up there. Okay, so I'm going to use that, and then I am going to just use pencil, if I can get one, to do each of the questions. All right, so here we go. Number 2 says that RV is 4 and VT is 16. Oh, wait, before I do that, hold on. I want to go back and highlight my matching sides. So I know that Papa Bear is 3 hypotenuses. So I know that Papa Bear and Mama Bear, so Papa Bear's long leg is Mama Bear's hypotenuse. And then I know that Papa Bear's short leg is Baby Bear's hypotenuse. So I know those two. And then I also know that Mama Bear and Baby Bear share a leg or a side because that's the altitude that we split down. So Mama Bear's short leg is Baby Bear's long leg. Okay, so that's going to help me match up my sides. All right, so now we're ready. So if RV is 4, so RV is right here, and that is 4. and VT is 16. So VT is 16. And I can tell since they don't have any colors, they're not matching anywhere else. We need to figure out SV. Well, SV is right here and right here. All right, so the first proportion is pretty straightforward. I have this and that. All right, so I'm going to go over here. And I know that, let's see, trying to get this all organized here. Maybe I need to back out a little bit. All right, so just to kind of start us off, I'm just going to write what's happening here with the sides. So RV and VS match up with SV and VT. Okay, so I'm just going to stick with the triangles. So I'm going to put 16 over X because that is my mama bear. And then baby bear's corresponding sides are going to be X over 4. All right, now to solve this, all we really need to do is multiply the diagonals together. So X squared equals 64, which tells me that side SV is 8. And there's the first one. All right, moving on to number 3. So I'm going to go to my picture and erase my markings because I'm using the same picture over and over again. So, all right, so this time SV is 6. So here's SV, but I know it has a match over there. VT is 4, which is this one, and we are looking for RV, which is this one right there. All right, well, this is the exact same setup that we just had on the last one. So I'm going to say 4 over 6 and 6 over X. So 4 over 6 is mama bear, and that matches up with 6 over X for baby bear. So if I multiply these diagonals, I get that 4X is 36, which means that RV is 9. And there's the second one. All right, so again, I'm erasing my numbers here on my triangle. All right, here's number 4. RV is 20. Okay, so RV is 20. RV is 20 right there. VT is 8, which is right there. And we're looking for SV, which is there and there. So it looks like we have the same setup again, and just pretend like these numbers make sense. Okay, so for this one, I'm going to say 8 over X. So that's mama bear, and she matches up with X over 20 for baby bear. So multiply the diagonals. I get that X squared equals 160. So that means that X would equal the square root of 160, and I know that 16 times 10 would simplify to be 4 square root of 10. So, well, I kind of messed that up, but that's all right. So SV is 4 square root of 10. Alrighty, so there's number 4. All right, on to number 5. I hope these get a little more entertaining. They're kind of boring so far. Okay, so RS is 15. So RS is right here, but I can see that matches with another side. RT is 25. So RT is this one, which is 25. And we are looking for RV, which is that one right there. All right, so this time we have corresponding sides between Papa Bear and Baby Bear. So I'm going to say 25 over 15 is Papa Bear, and that would match up with 15 over X for Baby Bear. So if we, there's different ways we could do this. We could reduce this one down, or we could just multiply the diagonals together. It really doesn't matter, but if we reduce this by 5, we get 5 over 3, and then we can see that RV is going to equal 9. All right, that was a little bit better. Okay, next up. Get these out of here again. All right. Okay, ST is 9. All right, ST is 9. So here's ST, and I can see it matches up with another. And then VT is 3, which is that one right there. And we need to find RV, which is that one right there. Okay, so when I look at this one right here, I am noticing that I have two sides of this right triangle, but I don't have the third. And then over here I only have one, which means I can't figure out the other two. And over here I only have one, which means I can't figure out the other two. So the first thing I'm going to do is use Pythagorean Theorem to figure out what this side is right here. All right? So if I do Pythagorean Theorem, I know that a squared, which I don't know, plus 3 squared, which would be 9, needs to equal 9 squared, which would be 81. So if I subtract 9 from both sides, a squared would be 72, which means a is going to be the square root of 72. Now, I'm not going to simplify that, and I'm going to show you why in just a second. So now, if I go back over here, I know that this side is the square root of 72, but I know that this side and this side are the same. So now, when I look, I have corresponding sides between mama bear and baby bear. So I'm not using this or that to solve my problem. I'm back using these two. Now, the reason why I left that is going to be clear in just a second. So for my proportion, I'm going to say mama bear is 3 over square root 72, and that matches up with square root 72 over x for baby bear. So now, to solve this, I get 3x equals 72, because square root of 72 multiplied by itself is going to be 72. So divide both sides by 3, and that tells me that RV is 24. And there's number 6. All right, on to number 7. So, get these out of here. All right, for number 7, we know that RS is 12, so RS is right here, which matches up with that one. Oops, sorry, I'm off the camera. So RS and RS are right there. And then we know that RV is 9, and we are being asked to find VT, which is that one right there. Okay, so this is a similar setup. I only have one side here. I really don't have any sides here. I have two sides here. So the first thing I'm going to do is use Pythagorean Theorem to figure out this side. All right, so Pythagorean Theorem would say that a squared, which I'm going to say is 81, so 81, plus b squared equals c squared, which is 144. So then subtract 81 from both sides, b squared would be 63, which means b is the square root of 63, and I'm going to leave it like that. So now I know that this side right here is the square root of 63, but I know that side is also this one, which is square root of 63. And so now, once again, I have corresponding parts between mama bear and baby bear. So that means that for my proportion, I have mama bear equals baby bear. So now I just need to solve. So 9x equals 63. That's what I get when I multiply the diagonals together. So that tells me that VT is 7. And there's number 7. All right, let's see, next up. All right, so those two were probably as difficult as they get because we had to use Pythagorean Theorem to get the missing sides. All right, so here we go for number 8. Whoops, almost picked up the wrong thing. Okay, RV is 5. So here's our V, which is 5. And then RT is 25. RT is 25. And we are being asked to find SV, which is this one right here, which is also that one right there. Okay, so now this one is really weird, which tells me that I probably want to go back and look at my original triangles, because I have one side here. I really have no sides here. I know what I'm looking for. And then I have two sides here, but not really. So I can't use Pythagorean theorem, and nothing is matching up. So what I'm going to do is I'm going to go back up here to the original picture. Okay, one thing that we should point out is all of these sides are separate except RT is VT plus RV. So in this problem, I know that this side right here is 25, and I know that this piece right here is 5, which by simple math tells me that VT must be 20. So now I can say that that's 20. So doing that, now I have Mama Bear set up, and you might even be able to do this without even thinking about it, but if not, we'll write it down. All right, so Mama Bear is 20 over X, and Baby Bear is X over 5, which means that X squared is 100, so SV is 10. All right, that wasn't so bad. Okay, let's see, number 9. Here we go. Last one of our right triangle similarity problems. Ugh, whatever I'm trying to say here. Okay. All right, so let's see. On this one, SV is 12. So I know this side is 12, which means this side is 12. RV is 8, which is this side, and I'm looking for RT, which is this side over here. Okay, so here's the situation again. I only have really nothing. I only have 1 here, I have 2 here, but I can use Pythagorean theorem on this one to figure out this side right here. All right, so let's start with that. All right, so Pythagorean theorem for this one. So A squared would be 64 plus B squared, which is 144, is going to equal C squared. So I add that together and I get C squared is 208, which means that C is going to be the square root of 208. And I'm going to leave that because chances are that'll serve me better in that form than any other. All right, so we just figured out that this side right here is the square root of 208, but I can see it matches up with this side over here, which is 208. So now it looks like I have corresponding parts between Papa Bear and Baby Bear, so I don't need that information right there. So for the proportion, I am going to say that Papa Bear is X over root 208, matches up with Baby Bear, who is root 208 over 8. All right, so multiply the diagonals together, and we get that 8x is 208, so divide both sides by 8, and that tells us that RT is, well, that'll go into 20 with 4, 26. RT is 26. All right, so that takes care of the triangles at the top. So now I'm going to continue on and just show you how the bottom problems work. So we learned that there's another cool application of Pythagorean theorem, and that is that we can use Pythagorean theorem to determine if a triangle is a right triangle, but also if it's acute or obtuse. All right, so what we need to do is just fill this in and then see what happens. So first off, this is A, that's B, that's C. So A squared is 16 plus B squared, and we want to know how does that compare with C squared. Well, when we add these together, we get 80, which is less than 81, And if a squared plus b squared is less than c squared, that tells me that we have an obtuse triangle. All right, on this one, be careful because this one right there is your c, because c is always the biggest side. So we'll say ABC, so a squared plus b squared, and we want to know how that compares with c squared. Now, I know my squares pretty well, and you might not, so you might need to do a little math there. All right, so let's see. If we add these together, this gives us 468, which is less than 484, which makes this triangle obtuse. All right, next up, 8, 15, 17, so that's C, so I'm just going to say ABC. So a squared plus b squared, and we want to see how does that compare with c squared. Well, if we add this up, we get 289, which equals 289, which tells me that this one is a right triangle. All right. Okay, so here we go. Let's think about this. So this is definitely not C. Between these two, I'm thinking that this one is the C. Now, there's a few reasons why. I'm going to call this A, but 12 would be 6 times 2. This is 6, or 6 times 1. This is 6 times something less than 2. So I know that the 12 has to be the biggest side. Okay, so here we go. So let's think about it. So a squared is going to be 36. Plus 6 square root of 3 multiplied by itself would be 36 square root of 9. So here, let me write this out. 6 square root of 3 times 6 square root of 3 would be 36 square root 9, which would be 36 times 3, which is 108. And we want to see how that compares with c squared, which is 144. All right, well, we add this together and we get that they are equal, which makes this one a right triangle. All right, next one. So again, be careful because that's our C right there. All right, so I'm going to say a squared plus b squared, and I want to know how that compares with c squared. Well, 125 is greater than 121, which tells me that these two are acute. Or this triangle, sorry, is acute. All right, so now I'm going to come to 15. Now, 15 doesn't have any numbers in it, so we're just going to have to think about what if we put numbers in it. So let's say we put a 1 in place of c. So this is 1, that's 2, and that's 1 square root of 3. Well, 2 would be the square root of 4, so I know that this is my side C. Okay, so 2c is the biggest. All right, so a squared plus b squared. All right, so let's think about this. So if we had c square root of 3 multiplied by itself, that would be c squared square root 9, which would make 3c squared. Sorry. And then we want to compare that to 2c squared. So 2c multiplied by itself would be 4c squared. If we add these two together, we get 4c squared, which equals 4c squared. So this is a right triangle. All right, I hope that's okay. If you need to go back and replay something, obviously do. And I hope that helps with this worksheet.